getting everything going here. Please, any of y'all jump on. Once you jump on, let me know if you can hear the microphone and all that fun stuff. Just the usual mic check, mic check. I'm gonna be covering over some really cool stuff here. If you are a metal fabricator, if you're a roofer, you've ever like flashed a valley or a chimney or anything like that, you're gonna find this quite interesting. If you've done metal work your whole life, machining, things like that, be covered over some really cool stuff that I'm actually learning in my design studio. I'm gonna show you this Fallout 76 marijuana grow light design. I'm about to hopefully going to get manufactured this week and talk about the Nukeheads Da Vinci Grow Light coming up and what we're doing to build up to that. So again, just started the stream. If you cannot hear me, please let me know. If you can hear me, great. Most excellent day. Let's see here. Let me check over the microphone. And, yeah, mic shows good. We should be all right here. Maybe let me turn it down a little bit. Maybe I'm blowing your ears out. Turn it down just a notch here. Let's see there. All right. About 85%. Okay. Let me go ahead and close this out here. And studio checking everything at FPS 30. Let's frame rate. Let's boost that up to 60 because now I'm running an RTX 4090. Yeah, I'm running the big dog, and it is making a difference, y'all, especially with my ability to design things. So here's what we're going to go ahead and do. I'm going to cover over some things. I'm actually going to design a metal box here. Just kind of I'm going to give you the pain in the neck first-hand show of what we're looking at here. So looks pretty cool, right? Y'all seen me design a metal chassis before when I made the V2 chassis, but let me tell you how I did that. I did the V2 chassis as a flat square. Let me explain to you. And that's why it didn't come out as great. It looked cool. You probably couldn't tell. It was a ton of work. But basically, I had to, design out a little metal box like this, and let's say 0.12 millimeter. I had to, come in here and let me go back to that. And if you metal people, this is all going to make sense to you. This will make a lot of sense to you. But let's say, I'm going to be kind of making I'm going to be bending this on a box metal brake. So I need to, get my get all the little ears and all that made up here. So, I may do that on one side, do this on another side here, and then maybe I'll come in here and I'll have to add my little ears that I'm gonna bend on the metal brake. I'm not making them perfect here, just kind of giving you the idea of what you normally have to do, and then this right here would maybe be drawn out a little bit. Same down here. And over here to have little metal ears, and basically you're designing something that you're going to use a box metal brake or a pan brake to unfold into a design. And so that's how I did the V2 chassis. It was a real big pain in the neck. I can actually show you the V2 chassis design here. Let me jump on over to that. I'm going to just close this out here. Don't save. And let's see here. Where's the V2 chassis? Okay, the V2 chassis top. So I made a top and a bottom. And if you look at this here, you see basically we have this metal, one like 2D dimensioned metal sheet. So imagine a metal sheet, and everything you're seeing here is going to get cut out of it, right? So you see all this right here, and you see these little ears right here. These are all little metal box brake markers so I could put this on the pan brake. And let me see if I can pull up a let me pull up a video from the V2 chassis. I'll show you the V2 chassis here. So I'm gonna go to my Nukeheads YouTube channel here, videos, and we'll go down, 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 down. And there you go. There's the V2 chassis. So you'll see me in a here. Let me start it up. I'm gonna turn that off. So when you look at that chassis, looks really cool. I designed that and packed a bunch of electronics in there. I am going to be using the AC Infinity fan. In fact, I've got to start designing the AC Infinity fan. 4 of those fans, I made a dimmer. If you look at all 4 of the little knobs on the back of the scroll light, each one of those not only controlled the speed of the fan it's closest to, but it also controlled 6 of the 24 diodes. So you had 4 different controls on the grow light. And so here you can see just 6 of the diodes is being controlled with the one dimmer knob, but the rest of the diodes are turned off. So coming up with the Nukeheads DaVinci Grow Light, what I'm going to be doing is I'm going to be building a Windows GUI application using Visual Studio, C++, and Arduino IDE libraries, where you can tap a button on a screen. And I'm going to show you the screen here in a second. I'll give you a little sneak peek. But this video today that I'm doing on this live stream, I'm going to show you the difficulties of this metal, making a metal box. So even though this metal chassis came together, it was kind of hacked together. It was very rudimentary put together, um, and it was a lot of work. And to get it right the first time around, I was very proud to actually just get it to work. But if you look here, let me let me pause it right here. If you can look at my mouse, there's little screws. You're gonna let me bring it forward some here. Okay, if you look at these screws right here, where my mouse is at, if you can, yeah, you can see my mouse. The little screws right here are metal sheet screws. Okay, they're self-tapping sheet screws, or something you'd shoot in like red iron with, or what have you. And if you look over to the left side, over here where my mouse is at, on the left side of the grow light, you'll see that you cannot see those nuclear symbols because the box that it's basically a box inside of a box. So it's like putting a pizza box inside of another box. And then they're screwed together, and I put all the electronic components into here, and even put a polycarbonate glass lens on it, and it turned out phenomenal. I mean, it looks phenomenal. It's just that I know of the imperfections. And here you can look at the metal box design right here as I'm doing a bending, breaking, and having to weld this box here. I'm showing you um, the 2-part design. So there you can see one part slides into the other part, and I did this painfully, man. I did this painfully by 2D designing because I did not know at the time how to 3D design sheet metal. It was just a new concept to me, and the precision there, it just it was there for me all along, but I didn't know it. So let me give you an example here of what we're talking about, or what I'm talking about. So that's the V2 chassis. I'm going to close this out. And so basically, all of this was measured out. But let's say I wanted this hole right here perfectly. Let me turn this whole thing into a hollow point. Hollow real quick. To a solid. Okay, so when this thing was all bent up, if I wanted this hole to line up with another hole, I didn't know how to do it. Doing it this way was not going to achieve that. What happened? These these radioactive symbols right here, they were being like basically covered up by the box that went on the inside of the chassis. So beyond the beautiful paint and all that of the design that you really couldn't see inside of there was these little imperfections. Well, I figured it out, y'all. I figured it out, and boy, I lost sleep last night. I got so excited about this. I lost sleep trying not to think about it. So here I've got a V2 chassis plate. Okay, so I'm going to go at this. I'm doing this for a couple of reasons. What I'm going to learn by putting this together, and it's the Fallout design. I'm going to probably build it this week. Um, what I'm going to learn from this is how to have a four-dimensional, or I'm sorry, a three-dimensional design that when it's turned into that square box, the holes line up. And it's because there's a feature built into my computer-aided drafting software called sheet metal design. And I didn't really know how to use it because it was really like mentally like mind-boggling to incorporate a sheet metal design into a three-dimensional design and have everything just kind of like perfectly line up. So here I got the holes, this hole going through here. What if I could take this box right here and make it flat and then put it on a machine and have it cut to where when this outer metal edge right here is put together, it lines up perfectly so that this inner edge right here lines up and both those holes line up. Well, it can be done, and I figured it out. Let me I'm going to hide all of these components here so we can look on the inside of this grow light here. I'm going to hide the metal plate. Let me hide the body, man. So here, you sheet metal people, you'll probably be like, "Oh, I do that all the time when I make a box for, roofing, like a little roof box, or I'm flashing, and I got to go around a chimney." You learn how to tuck these ears and stuff. So here's all of it designed together, and up here to the left is a sheet metal option, and I never ever dabbled in this. And when I did, I was like, "Oh, it doesn't work. It's like for freaking aliens to learn how to use or something." And I got it right. You see these holes right here? I need to be able to bend this metal sheet. Let's do a render. I'll show you a render of it. See if the computer can handle a render while live streaming with the GTX 4090. I'm pretty sure it can. Yeah, that is what it's going to look like when I take a flat sheet of metal and it together. But for the first time, I need holes to line up, and there's a lot of problems that I'm going to be facing trying to get this. And I'll tell you what those are. This way, I could show you visually with this $2,000 graphics card. I went and spent the money. If you're a video gamer, you know what the RTX 4090 is, and it was like over $2,000. But for the kind of work I do, I need to be able to have that graphical power, or that kind of graphic processing power to do this kind of stuff. So you sheet metal folks are looking at this and you're like, all right, that's pretty neat, where are you getting that, Cody? What's going on here? So if I have a 2D design, or I have a 3D design here, and this sheet needs to be turned into a 2D design so that when it's bent up, these holes all align. And look at the bottom of this plate right here. See this gigawatt plate right here? It's a typical 24 diode gigawatt, and I have holes in it. So the gigawatts coming up that are going to get cut have these holes right here. And I don't know if I want to do some pop rivets, if you know what a pop rivet is. So I've been measuring these, get this in front of the camera here. So I got some metal rivets. I also have something I never knew existed before. These are going to be powerful when I come up to do the DaVinci design. These are called rivet nuts or clinch nuts. I never knew these things even existed. I was shopping on my wholesale screw and nut website, to do a bulk order. And I was like, what the hell is a clinch nut? I seen this thing called a clinch nut. What the hell is a clinch nut? So I go Googling it. I'm like, oh, oh my gosh, I should have known what this was before. So this has threads in it. This is for an M6 threaded screw. Basically, it's like a pop rivet. If you think of a pop rivet, only it stays hollow. It has nothing in the middle of it. So it will squeeze itself down flat to a piece of sheet metal, and it lets you screw stuff into it. So I'm like, okay, I know exactly how I'm going to use that when I designed the DaVinci design, because inside the grow light, inside of the grow light, I'm going to need a place to mount a computer and an Arduino and some other like um, pulse width modulation control boards for AC variable dimming of the grow light. So this time around, I don't want to use analog like controllers to dim a grow light. I want to have a touchscreen. I'm going to show you the touchscreen. I'm going to show you some of the electronics coming up for the DaVinci here as a teaser in a little bit, so you can follow along. How are you going to put a Windows 11 Pro operating system into a grow light with a touchscreen, and you're going to control this grow light through this touchscreen using a Windows operating system? And yes, that's exactly what I'm going to do. And I'm going to show you some of the things I'm going to buy to do it. But back to this precision machining process here. If this goes as I'm designing it here, and I'm going to show you. So if you look at the plate here, the plate lines up with the holes in the sheet. So I'm going to put one of these rivet nuts right through here and right through this metal hole right here, or this hole. Hole in blue lines up with this hole right here. And that is going to be where the grow light hanger goes through. So I'm going to be putting one of these rivet nuts through there, clamp it down. And before I go, I have never used one of these, so I bought a gun. Like the rivet gun is a pneumatic air controlled gun that does this stuff. I've never used one of these, so I'm going to practice on like a gamma ray. I'm going to kind of learn how to use those rivet nuts, because they're going to be very integral to not only this design but the DaVinci design. So here's here's the lowdown. If you look, I'm going to have to take this metal sheet and bend it where these outer ears right here, they're all going to have to be bent where these freaking holes right here, which I'm either going to pop rivet the plate. So when you put the plate on there, I'm going to pop that plate back on there, remove the plate, put it back on. Heck, I'll turn it into glass so that maybe we can kind of look through it real quick. Look, I'll turn it to glass. So if I turn that metal sheet into glass so we can see through the grow light design here, you'll see that these holes line up with the holes going around the metal box. Now, in the real world, I've got to bend this metal box. Imagine if let me hide that. Imagine right here at this bend right here. You see this little bend? And this bend has a radius right here. If I don't bend that perfectly, if I'm just like 2 to 3 millimeters off on that arc, if I bend it, then this right here, this whole area right here, let's see if I can get it. Oops, darn it. Let me hide that. This whole area in blue will be longer if I don't bend this at the perfect arc. So at that bend point, if I make it too short, it's going to move this hole back a half a millimeter or a millimeter or 2 millimeters. And what will happen is it won't line up with the hole on the gigawatt plate. So I am doing this to really press 3D design and sheet metal combined to see what precision and I can achieve here. And I imagine that I'm gonna have to cram my hands up in there and push on each each side until the holes line up. But how do I get the metal bend perfect? How am I going to put this thing on a metal brake and bend it at the right point so that all these freaking holes come together and this thing comes together the way we're looking at it on a computer screen. In a computer world, everything's perfect, right? But you know, when you're actually physically bending this on a metal brake, um, we're going to be a little bit off. We have to have a little bit of room for tolerance and error. And I'm going to show you how I'm going to do that. So let me get rid of this box here. Here's the cool part about what I freaking learned with the software. I'm going to jump down here, hide the power receptacle, switch to sheet metal mode. I'm going to, with a click of a button, I'm going to turn this freaking metal box into a flat sheet that we're going to be cutting with a Omax water jet cutter. And boom, there you have it. So this is how I'm going to be able to cut this sheet with a water jet machine. And when I bend it, everything will come together perfect. And even more nice is it is letting me come in here and is showing me, okay, you're going to bend this metal at this line. Well, on a computer, that line is there for me to see, but when the sheet's actually cut, this is what I'm going to be looking at. I'm going to be looking at like the solid freaking sheet, and I'm going to have to like bend it as best as I can. So here's a little hack. Here's a little cheat that my mind came to me. Well, I couldn't sleep very good last night. I'm like, oh man, I'll just like cut little bend lines into the 2D flat sheet, and um then I'll know where to bend the freaking thing at. So what I mean by that is I'll come in here and I'm going to make some edits to this 2D flat sheet. Now that it's in a 2D flat sheet mode, whenever my computer wants to comply with me, and I'll come over and I'll show you a quick and dirty fabrication of a box using this 3D software. And this is mostly for folks that really like kind of understand like the bending process of bending metal. Boy, this thing is, boy, she wanted to lock up on me. Okay. So I'm going to do a center rectangle. I'm going to come here to each one of these lines right here. And I'm going to do a 1 millimeter wide by, let's do 5 millimeter long. Okay, there. Now I'm going to cut this freaking little edge out right here. Just like that. Bam. All right. Now what I've done here is whenever I put this piece of sheet metal on the brake, I'm going to know that I need to get the very front of the teeth of that sheet of that metal brake. I'm going to have to get it right here on this little cutout. And that will make sure that I have a center on my radius when I go to bend this guy. And that way everything is close to computer accurate design as I can by physically bending this Growlite, Growlite sheet metal. So those holes line up perfect. And if I achieve this one, then I don't think I'm going to have any problems with some of the complex chassis design coming up for the DaVinci. And I'm about to show you what I'm going to put in the DaVinci Growlite. You're going to get to see some really cool tech that it's going to ramp the price up to that thing. Like, I don't know if I'm really going to try to sell the DaVinci. I don't know, because the problem with it is cost. I mean, we all know we can grow with $300-$400 grow light that doesn't have all this advanced tech in it and do amazing and do well, right? The DaVinci is not about that. It's not, it's going to have the latest, greatest Samsung technology in it, um, a Windows operating system, a CO2 sensor. I mean, it's just going to have all kinds of tech put into it. But the problem is for me to sell that thing, I don't know if I'd want to sell it after I build it, but I'd probably have to get like 4,000 to 5 grand for it after what I'm going to put into it. So it would be, someone that really wanted the most advanced grow light in their operation, and I would warranty it for 10 years. Let's see here. So I've got to cut these little and I can do this later. This is actually something I need to do later on. It's not all that interesting for you to watch me cut little brake lines. So let me jump on over to showing you some of the computer tech. This little square cutout, I've got to do that for every one of these little center lines that you're looking at here that are turning black. I've got to do that for every one of them. And then I've got to come back over here, say finish flat pattern, and have it regenerate itself into a good flat pattern here. And now you probably won't be able to see it very well. One of these little areas right here, I should have a little cutout right there. Okay, if you notice that little cut right here, and right there. So this way I can easily bend that and achieve the closest to perfection as I can get it humanly possible. Let me go ahead and put all of the components back. And I typically don't design the wires into the grow light. I could, part of me, like my OCD, would absolutely design the wires inside of this grow light if space was super crunched. Like I needed to truly have like every little piece of the design figured out for consolidation of space. But I have a lot of grow light equity here to have wires sitting inside there, and I'm not going to have to be very like chinchy on how much on how much space I'm using up. And change this over to aluminum. Switch back out. Bam. So I'm going to use the current gigawatt plate design that I've been using. The reason why I'm using this plate, again, I'm trying to see if I can achieve this perfection on a standardized plate, and it does two things. This opens up the option for me to make you a custom designed gigawatt with a fan controller in it and air cooling. A lot of you have been telling me you want the some kind of cooling for the grow light. The metal plate acts as a heat sink. I could add additional heat sinks in there, but it really wouldn't be all that beneficial. The other thing that I am planning on doing is making 2 circle drop-ins, like 2 like 4-inch holes. Let me see if I can give you a quick and dirty here. Do 4 inches, and just, I'm not going to try to keep any perfect symmetry here. I'm just going to do this for visualization purposes. -1 inch. So I have these 2 round circles here, and what I want to do is design a sheet metal round port for you to hook your inline fan up. So one thing that LEDs don't do anymore that you got with an HPS was inline cooling. So now you can have fans and you can have heat sinks on your LED grow light, but it doesn't make a shit because all a fan does and a heat sink does is it takes heat from one area, which is in this case the source of heat would be the diodes. It takes the heat from the source, or it takes the heat from the diode, and it absorbs it into the heat sink, right? And what does the fan do? The fan takes all that heat absorbed into the heat sink and it disperses it. So effectively, what do you got? You got a heater. Your grow light is just, with the heat sink and a fan, it's just acting as a heater. It's putting heat in your grow tent. That's why it doesn't matter if you have heat sinks and fans or you don't. If you have a 700-watt grow light, like the Gigawatt, for example, and you put in a 4x4 grow tent and you put a 700-watt grow light of any other kind of, I don't care what the grow light is, if it doesn't have an air conditioner built inside of it, if it's just 700 watts with fans and heat sinks, in one day of being left in the grow tents, both grow lights are going to be the same temperature. And the reason is your heat sinks and fans, people have this misconception that, oh, a fan and heat sink takes the heat out of the grow tent. It takes the heat. It doesn't take the heat out that your grow light's producing. It just cools off an area of your grow light, like your diodes, so they can last longer. And it takes that heat and it puts it somewhere else. The only way you're going to get heat out of your grow tent is you have to remove it. And I have an ideal for LEDs, which is basically the old HPS days. Let me see if I can bring up an HPS hood and show you for folks that probably don't know what a HPS is, that probably just started growing. HPS with hood vent. So here you go. Here's a, here's a perfect example right here. Oops, let me back out of there. You got ventilation, HPS grow light with hood ventilation. Okay, so maybe I can make this guy a little bigger here. Okay. All right, there you go. So if you notice, there's ventilation going in one side of the grow light, and then ventilation going to the other side of the grow light. And there's a fan. You can basically connect one of your AC Infinity 4-inch or 6-inch fans to like 10 of these grow lights, or heck, even 50 grow lights. Those fans are really powerful. You could probably do like 50 grow lights like this. All of the heat that this HPS bulb is generating inside of that container, all of that heat's is getting pushed right out of the grow tent. My wife is calling me while I'm live streaming. Isn't that interesting? I have to answer this. I'm live streaming. Is everything okay?
Oh yeah. Okay, never mind.
All right. All right. I'll get you back.
Okay,
Bye.
bye.
Gotta make sure it wasn't like a car accident or something. Okay. Um. Okay. So, anyways, there's since the advent of LEDs, people have had this misconception that, oh, I don't need to exhaust my heat anymore. Like I got an LED. Well, when LEDs first came out, they weren't really all that bright. They were, 130 watt LEDs. Let me see here. They weren't really all that bright. They were like 130, 200 watt LEDs. Very first LEDs were like $500, man. They were really expensive for a tiny ass little LED. And everyone thought that little ass LED was going to grow your plants big as shit. And, was, the next, they're supposed to be brighter than HPS. And it took years for people to actually want to move to an LED because HPS was still stomping the dog shit out of LED grow lights. It and here's why people finally did move to an LED grow light. because LED grow lights came down in price, and the only way an LED grow light truly started competing with a HPS is when they started making 1,000 watt LED grow light, and 1,000 watts of anything, whether it's 1,000 watt HPS grow light or 1,000 watt LED. 1,000 watts is 1,000 watts, and that's still going to be 3,140 BTUs of heat, because 1 watt equals 3.14 BTUs of heat. It doesn't matter if it's an HPS grow light, it doesn't matter if it's a refrigerator, it doesn't matter if it's your watch. If your watch could put out 1,000 watts, if your watch was 1,000 watts, then it would be as hot as a HPS grow light. So people really had a misconception because they don't know any better. They thought that LEDs were cooler and all that, but they're really not. 1,000 watt LED is every bit going to put out the same amount of heat. It's going to make your grow tent as hot as a 1,000 watt HPS. The laws of thermodynamics don't change, and I'll end that one here. 1 watt equals 3.41 BTUs of heat. So if any of you are like, oh, that's a bunch of crap, my LED is real cool, and all right, well, whatever, man. Here's the basic all along. 1 watt is equal to 3.41 BTUs of heat. So it doesn't matter the technology. It doesn't matter what LED technology you're using. When you have 1,000 watt LED, the sucker gets hot. It makes your grow tent get hot. It doesn't matter if it has heat sinks or and fans. It's still going to get hot. So here I'm designing this grow light, and I'm going to put a fan in it. All that fan's going to do is take that heat and disperse it out. How do we get the heat from the grow light out of your grow tent? We'd have to go back to the HPS hood days, where we're taking that heat and we're venting it out, and not necessarily having to use an air conditioner. We use a cheap fan to do it. So the way I have this planned is, after I'm getting better with the sheet metal designing process, I'm going to take this chassis, all these little holes with these nuclear symbols and things like that are highlighted, and you're seeing here. I'm not going to have that built into the grow light. It's going to be a solid box, because we don't want the heat going out. We want the heat trapped in and ventilation to vent it out. So basically, in this hole here, to the right, we'll have your fan air blowing coming in, and the center fan hole here will not exist. This is for an AC Infinity 110 volt fan to cool this particular design. But when I make this ventilation design, this center one will not exist. It'll be an in and an out. Air going in, air going out. That way all the heat built in your grow light is getting just sucked out of your grow tent, out of your house, or out of your grow operation, and is no longer a problem, while it's also cooling your grow light. Nobody seemed to have thought about this, because they've gotten lazy and complacent. The Chinese are just pumping out LEDs, but they're pumping out now. Everyone's getting used to 1,000 watt, 500 watt, 700 watt LED grow lights running Samsung LM301H, and I've already shown plenty of video that they get your freaking grow tent really hot. People used to be like, oh, your gigawatt gets my grow tent up to 90 degrees Fahrenheit. Okay, what is your 700 watt LED getting your grow tent up to? Oh, well, you don't have one. Yeah, because they're expensive, right? And what I've done is I've taken 1,000 watt of LED power, and I've made it affordable, because most of you are not venting the heat out of your grow tent, because there's complications there. If you're saturating CO2 in your grow tent, you don't want to take out your CO2 and just blow it right out your grow tent. But this design that I'm talking about coming up, with ventilation built into the chassis, will let you pump all the CO2 into your plants while completely removing all the heat of your grow light out of your grow tent and out of your house. So that's what I got. It's another little trick up my sleeve, something I'm going to be designing. I just got to get my hands dirty and feel confident with the sheet metal design. So here we are. Let me stop playing around with this. Let me get rid of those two holes there. Bing, bada, boom, bada, bang. So today I do have to design the fan. Technically, I don't. I could just cut this as you see it. I know that those holes are perfect for a fan, because I've already used this design before. on my V2 chassis. But I actually want to, see the power cord mount right here. And please forgive me for those that may not know any better. I have always had a speech impediment issue, so my mind runs faster than the words coming out. So sometimes my words are a little bit pitched and dragged out, or delayed, or shortened and compressed. Um, but I do my best, man. I do my best. It's like Mike Tyson has a lisp problem too, but his mind runs so fast. People think about Mike Tyson hitting you and hitting you like a ton of bricks, but what a lot of people don't realize is when you watch Mike Tyson in his prime years, Mike Tyson almost never got hit. It's like the man's mind ran so fast that when he was boxing, it was like the other boxer was slowing down because you really couldn't hit Mike Tyson. He just bounced around, and the uppercut comes and somebody falls down, and it's over. So yeah, I kind of know a lot of people with speech impediment. My children all got my speech impediment too. We have just ADHD, and our brains run a crazy, they run crazy fast. So our sometimes our presentations are nice and funny, or they're unfiltered. If it's in here, it comes out my mouth. So I try to do my best not to make sure I don't offend anybody. So there we go. That is that. I got to design the AC Infinity fan. Let me jump on over and show you the fun stuff. Then I got to get off this live stream because I have someone building grow lights for us right now. If you ordered a gigawatt from us, I have a person that's actually working on building their grow light, their first grow light with us, and hopefully will help us keep up with all the orders because I am not having any issue selling them. I am having problems keeping up with how many we are selling. So if you want a grow light, a gigawatt grow light, right now we're about 10 days behind, but I'm hoping by the end of this week, we probably won't be behind, and I will remove all that 2-week lead information on the website. So now let's jump over to the fun stuff. Let me show you what I got going on here with the DaVinci design. So considering that I build this Fallout 76 themed grow light, and it goes as you see it here as it is designed. I'm going to be doing this right here. Let me make sure my camera is not in the way. Let me drop me down here. Drop me down. All right. So here is some microcomputers. Some of you are wondering, like, how are you going to put a Windows operating system into a grow light, Cody? Let me show you. There's some really cool, small and compact computers. Now, I have a little $200 option here. I have a B-Link. I've been looking at this B-Link for a while now. This $419 guy right here may be a little bit too much than what I'm going to need. I just need something that can run Visual Studio C++ IDE so I can write C++ code to interface the sensors. I'm going to be putting the same CO2 sensor that I used in my CO2 regulator. I'm going to be basically using most of the code that I wrote for that. So it's basically, if you really think about it, I've already done all the work. I've built a handheld quantum flux density meter. I built a handheld uh, EC meter. I built a handheld pH meter. I built a handheld moisture meter, and I was going to design an NPK meter. I actually tell you how much nitrogen, phosphorus, and potash you have in your soil. Milligrams per kg of soil, so you can see an exact amount of nutrients that you have in your soil. I'm going to build that soon. I got to get that one off my chest because I really want to build that design. It's going to be easy. The DaVinci is going to be the hardest thing ever that I've ever built for in the grow light and marijuana industry. So here I have a nice little compact grow light. A little pack computer. I'm looking at the breakdown, and the reason why I'm staring at this thing, I'm thinking in my head, can I take it apart? Can I just take this little guy apart, or should I just epoxy it on? Should I take it apart and screw holes into the little chassis for the computer and then bolt it down into the DaVinci grow light? So this is the kind of approach I'm coming in at. I'm thinking about these kind of things. Then I need a touch screen HDMI display screw on panel. See if I can find the one I found earlier. So I'm looking for something that I have to, yeah, here we go. Bam, there it is. So here, if you notice, I have a showing a Windows operating system on there. It's very attractive. Watch the little video here. Speed it up. So yeah, so here I got a 7-inch green TV that has a resolution of 1024 by 600 with HDMI. So I can interface this to the little microcomputer that I just got through showing you. And do you see the little mount hole? So I'm going to have the computer draft. Basically, I'm going to have to make a 3D exact replication of this design, fit it into a metal chassis, and plug it into a into that little B-Link computer I just got through showing you that has Windows 11 Pro. And here's the cool part about Windows 11 Pro. Windows 11 Pro, because it is a Pro version, lets me remote desktop into the unit. So what I could probably do is I'll get the little computer connected to my Wi-Fi my local area network. Then I'll set up RDP on the little microcomputer, and then I'll remote desktop into it from my laptop. That way, when I have it plugged into a whole bunch of electronics and I'm testing up, the PAR sensor and this and that, I will be able to um, do it from my laptop using remote desktop until I get to the point where I'm ready to plug the screen in, drop all the electronics into the chassis. So I have a lot of little things that have to happen. I'm trying to think if I'm going to put a quantum flux density sensor into the grow light. How do I want to? What am I going to do? Do I want to make it a motorized drop down? Like, do I want to take like a stepper motor controller and have it like I'll 3D design a little spool, like think of a little wire spool, right? Like a fishing, almost like a fishing pole kind of spool. I'll design a little spool with some bearings and a bolt, and it'll drop down the par meter. Like you can push a button on the touchscreen and it'll drop down a par sensor. And then you can measure the par at the top of your plant as an integrated PPFD sensor module. Um, and the reason why I'm using Windows 11 is because I have, as a programmer in Windows and in Linux. Um, Visual Studio C++ lets me utilize GUI frameworks, like being able to program an application that has buttons and stuff like that very quickly using native C++. And I can use Arduino IDE libraries to be able to read sensor data from GPIO output. So if maybe you're not familiar, um, I'll come over here and we'll take a look at an Arduino. Amazon. So I'll be taking this guy right here, and the CO2 sensor, the PPFD sensor, the moisture sensor, the temperature sensor, the hopefully I can do temperature. There is some limitations, but the beautiful part about all this, if I can't, I'm going to use this one board, but if I can't, I can use two USBs, two different COM ports, programmatically set a handler to two different Arduino boards for you that may be programming individuals that understand the terms. I'll have basically I can set a an address or a variable to each one of these um, each Arduino. But this has 64 pins. It has quite a bit of pulse width modulation pins. I got a lot of pulse width modulation pins to work with here, so I should have plenty. I should have plenty to do the job for the DaVinci Grow Light. And now, what about dimming? Here's what I'm going to do for dimming. AC variable pulse width modulation dimmer. Arduino.
Let me pull it up here. Here we go. So here I have a pulse width modulation AC voltage dimmer that runs on native US 50 to 60 hertz AC. It can take 80 to 240 volts input. Um, and This is a dimmer. So what I'm going to be able to do with it is control it with that little computer, the little mic, the Arduino computer board I showed you. Looks like they have a video here. We'll watch the video real quick. I'm just gonna I'm just gonna speed it up to where we're seeing the dimming. But each one of these little boards has integrated circuits or IC chips, which should be able to handle. The board is rated at 500 watts, so the gigawatt is too powerful for one board. And plus, I want because the gigawatt has 24 diodes, 24 divided by 4 is 6. So if you notice when you look at the gigawatt, there are 6 diodes per quadrant. So how I did things in the past, when you look at the gigawatt here, let me move my big old head out of the way in the camera. You'll notice that boom, we have in this quadrant 6 diodes. Over here we have 6. Down here we have another 6, and over here we have another 6. So what this is going to let me do with the DaVinci grow light that I'm going to design, I'll need 4 of these boards, one for each quadrant. So I can send a pulse width modulation signal to each one of these boards with a set GPIO pin that's a PWM pulse width modulation pin. And on the GUI, on the programming interface, you'll be able to tap, on basically the whole purpose for the touchscreen built into the DaVinci Grow Light is the whole screen is going to be an application. There'll be windows running in the background, but I'm going to program it so that it'll set window handle to max full screen mode, and that way, and I'll set it as the parent application so that it stays full screen and you're not opening stuff up in front of it and things like that. So it basically becomes like kind of like a kiosk, a dedicated, application that opens up, and I can set it to start on boot. So if the Grow Light ever gets rebooted and it goes back into, you have to log back into it. I'm gonna make you have to log into your Grow Light when I build this thing. You're gonna have to log into the Grow Light. Pretty cool, huh? But 4 of these pulse width modulation boards will be used to variable the AC voltage going to each quadrant of the Grow Light, independently controlling 6 different diodes, and it'll be controlled via the touch screen using Visual Studio C++, GUI framework for the buttons and things that you normally use on any Windows computer application. Using Visual Studio makes that a lot easier for me to handle the button and process controls, and the fact that it can integrate with the Arduino API lets me take advantage of the framework to utilize the ease of Arduino libraries for reading and controlling sensor and servo control output. So I can read in sensor data, read in the PAR from the PPFD sensor. I can read in humidity, temperature. I can even, I'll be able to use the Visual Studio framework to show a little area showing your vapor pressure deficit. And you can pull it'll also, like with the PAR sensor, reading the CO2 and reading the PAR. When you put the PAR sensor down to the top of the plant canopy, um, it'll read the CO2 in, it'll tell you how much PAR you have. And what I can do with this is I can make it read the PAR, read the CO2. And I've been teaching a lot of you for years now that I found that marijuana is very picky. It doesn't like having too high of PPFD. So a lot of you people have been buying $1,000 grow lights and killing the shit out of your plants because even if you're like, Cody, my pH is right, my pH is perfect, my EC is perfect, everything is perfect, but my plants are frying up, and you're putting 2,000 ppfd on a plant, but you don't have like CO2 gas burners and CO2 tanks. You know, you're running these stupid little products like these little canisters you shake up and they release CO2, or little CO2 bags, which are mycelium. They're decomposing matter and releasing CO2 as a byproduct, but it's not releasing it fast enough for marijuana to ingress that CO2 for photosynthesis in order to keep up with the high PPFD grow environment that you're putting it under with these too powerful of grow lights. So what I want to do is I want to make this grow light smart. That's why was probably the most complicated thing in the design was for the grow light to read PPFD and automatically dim the grow light to the perfect PPFD. The amount of what it's going to have to do there is if your room is at 350 parts per million of CO2 and the grow light is reading 350 parts per million of CO2, you should be running no higher than 2 times that in PPFD. So you shouldn't be growing. You shouldn't have a grow light pumping out higher than 700 PPFD on the top of your plant's canopies. Especially most of your soil growers are not fully optimized. Marijuana just really doesn't like getting too high a PPFD when it can't breathe in enough air. It's like me dragging you with a truck and putting a straw in your mouth and some duct tape over the straw so you can only breathe out this little ass tube, but I'm making you run at a consistent 10 miles an hour, but you're still sucking out the little straw. You're going to get burnt out. Something is going to be imbalanced in your respiration process, to say the least. So that is one of the most advanced features that it will happen either both automatically, or I may have it not auto control the PPFD. I may make it optional and on and off. Auto control yes, or auto control on, auto control off. Where I can make it just tell you, hey, PPFD too high, dim grow light with the Windows application. So it'll read the CO2 in. You'll have the PPFD sensor at the top of your plants. It's reading everything, and it will tell you as the grower, hey, lower PPFD. So you lower it, it'll tell you raise PPFD. You raise it, and I'll make a range of window, a tolerance. It should be between this and this, right? Dim the grow light to this much. So you can dim it, get it within that range, and it'll maybe turn green. Say everything is good. So you're not frying up your damn plants with too high of PPFD levels. That's what these little boards that you're looking at in the screen are going to be able to let me do, combined with the CO2 and infrared CO2 sensor. So I'll show you the CO2 infrared sensor. It is the same one that I use for my CO2 regulator. CO2 IR sensor DFR robot. Where are you at, guy? I haven't bought one of these in a long time. I actually bulk purchased these things. What happened to it? What happened to it? There we go, right there. Bada bing, bada boom. Whoever's giving this thing a low rating doesn't know how to use it. This thing works great, highly accurate. So this is a infrared CO2 sensor, and I normally order these off out of China because they're too damn expensive. But this is the little sensor here that I used in my design here. Let me launch the YouTube. YouTube channel. So the beautiful part is for the DaVinci, the main challenges I'm gonna have for the DaVinci Grow Light is Visual Studio probably writing the visual application, which I've done that plenty of times in my past. I've written visual graphical applications in Windows. I just never done it to read control sensor data from Arduino. But apparently it's not going to be all that hard. I've been watching videos. I'm like, oh man, this This is great. It's going to plug right in. So there is my CO2 bot. I called it the Nukehead CO2 bot. Believe it or not, I sold probably more of these than I cared to build. Because what I'm doing here is I'm comparing my CO2 controller to the Titan Atlas One. That Titan Atlas One CO2 controller, at the time, it was like $580. I built my CO2 controller for roughly around $110, and I made it perfectly match the Titan Atlas, and I made it read faster because mine is computer process controlled. So here you'll see it, reading. And if you look at these numbers here, on average in America, on typically our highest ppm of CO2 you have, like outside right now, as the wind is blowing, if you're lucky, you're at 450 ppm of CO2. If you're in your basement where the furnace is on and things like that, you have a little bit of gas burn off and CO2 as a byproduct. In the basement of your house, you'll have the highest CO2 level. That's where you really want to grow your weed. Look at here. If you see 370 ppm of CO2, that's about the average that you're getting. And when you put your plants inside of a grow tent and you're not sucking air from outside of your house into that grow tent, you're lower than 300. Yet you're buying these damn grow lights that are like 2000 ppfd. You're just fucking your plants all up. Please excuse my language. You shouldn't be growing with these grow lights, much of spending $1,000 on them when your environment is not perfectly built out for it. And that is why the gigawatt, so many people, too many people that don't know shit about plant biology and grow light technologies, they ask, how high a ppfd is your gigawatt? Well, the beautiful part about my gigawatt, it's designed to have crazy high ppfd in a concentration factor, using your grow tent as a concentration factor, and not lenses. So a lot of these grow lights that are really high ppfd have concentration lenses on them. The exception would be Samsung LM301H SMDs. They don't need concentration to hit crazy high ppfd levels. They're just very bright. You want a more softer distributed light intensity on your plant, not high concentration. So that's why a lot of people have pretty good results with the Samsung technology. But even the problem there is they're too damn bright. So a lot of people are growing bud that wants to get hard and dense, but it comes out kind of airy. If you're having problems with airy bud, usually it's your pH level. pH is number one. Numero uno problem, pH. Second to that is probably overfeeding, causing you to grow some airy or funky looking buds. You don't have pH balance and you're overfeeding your plant. Everybody wants to overlove their plant. And the last but not least, your grow light is way too freaking intense. You have it. You have too strong of a grow light, and you don't have enough CO2. Remember, plants breathe CO2. We breathe in what? Oxygen, right? When we breathe out, like CO2 is coming out of us human beings, and plants, they breathe that shit in and they breathe out oxygen. So we have this beautiful symbiotic relationship. So a plant is breathing in CO2. You need to know that a plant's breathing in CO2. If you're going to make it work to death, like you're working it out in a gym and you're going to work it into a CO2 deficit environment, it's going to grow. It's going to turn like a tweaker. It's going to get all skinny and like it hasn't eaten and is being worked to death nonstop. You can't be growing a plant in a low CO2 environment and working it to death. So you need to reduce the intensity of your ppfd level over your plant. So I'm going to use my design of reading CO2 here, where I make my CO2 controller is I set a control point with a knob, like, okay, you want the controller to turn on your CO2 regulator at 1000 ppm or 700. So I made it variable so you could adjust what you wanted it to. And if you look in here, my CO2 controller was reading at 410 ppm, and then it starts dropping down. When it first kicks on, it reads real high, but after it's running, it starts stabilizing. And now look, my CO2 controller is running at is reading 380 ppm of CO2, just like the Titan Atlas One controller is reading. So then I put the sensor side by side, and I start breathing on them, and you can you can see the Titan raised up to 510, my controller raised to 510. When you breathe on a CO2 controller, it'll go up a bit. So anyways, I basically used this infrared sensor right here. I used this DFR gravity analog infrared CO2 sensor to build my CO2 controller. So I already have all of the code I wrote for that. I'm just going to edit it a little bit, copy it and paste it into my design for the DaVinci Grow Light, because all I'm doing is reading how high a CO2 or how just reading CO2 level. I'm not trying to read CO2 and then kick on an AC relay that is going to turn on your CO2 regulator controller to open up a gas tank valve and open and start saturating CO2 into your grow tent. That's what my CO2 controller was for. This is not going to be that. It's going to be a lot more simpler. I'm just reading CO2. It'll be bada bing, bada boom, and the DaVinci will be reading CO2. So there you go. There's some of the applications. Let's see here. I already have custom designed and custom engineered 5-volt VDC sensitive quantum flux density sensors that you cannot buy here. I had them made in China. They're the only place I could get them and get them down affordably to be able to sell you a custom built quantum flux density meter. So I already have my code written for my PPFD sensor. I'll just use that. So everything's going to be boom, boom, boom. All the sensors aren't going to be much challenge. It's more about it's going to be more about using Visual Studio IDE for the logic and programming control, the loop control for reading the data. And from what I'm finding, I'm probably not going to have any issues. It looks like they've already integrated Visual Studio with the Arduino IDE temperature. Arduino. So here, I'll probably go ahead and just take this guy right here, and I'll integrate that as a basic temperature sensor inside of the grow light. I use this temperature sensor. This is a very common temperature sensor. If I want to use pH controls, I have a whole bunch of this pH module here. I use these for the custom handheld pH meters that I designed for y'all. I have a whole bunch of pH meter boards for that very purpose. So I can also make the drop down tool. So I'm thinking about designing a little tool tray that you can pull in and out of the that you can pull in and out of the grow light. So you have a grow, you'll have the grow, and I'll put magnets on them so you can slide it in. It'll magnetize and suck in. So that's another reason I need to get the sheet metal design process down, get comfortable with it, and then put it to use. So I'll have a temperature sensor, PPFD sensor, pulse width modulated AC variable control boards, CO2 CO2 sensor, and then we can go ahead and do also. So if I put an EC meter and a pH meter sensor into a freaking Arduino, into this grow light, these are really tools that you use to, like, insert into your soil or your hydroponics and measure it. The only problem with this approach, if I put these sensors into the grow light, is that you have to calibrate sensors, man. You have to like calibrate a pH meter and you have to calibrate an EC meter. So what that means, I'll have to make an access panel where you can get access to being able to calibrate those sensors. So I have to design that. That's part of the chassis design stuff that I've really got to get banged out, got to get it figured out. And once I hammer that part out, so that comes back to the sheet metal design stuff. So that's why I'm building this design first. This is the, like, once I build this, man, building the DaVinci is not going to be anything, because I'm going to have like another layer inside of the grow light will be another little layer with, if you ever see PC stands, like, it's hard to explain, PC pegs, they basically rise, they're like little risers. I'm going to have a little riser sitting off of the grow light so that it's not getting hot. So the computer I showed you, that Windows 11 Pro computer, cannot be sitting on a hot surface. It's going to have to be raised up and having a fan blowing over it to keep it from getting hot. And it's already going to be hot because it's a computer, right? So I have a plan for exactly how I'm going to achieve that. Basically, all the electronics are going to sit risen off of the main board. And then all of these diodes are not going to be my current diodes. I have LM301H, all new. These are completely under test right now at the Yoxo lab in China, who are custom designing these for me because I spent tens of thousands of dollars with those people. So they're more happy, and I've showing them the whole project. They're like super happy to see what I'm doing with the platform that they designed, and they custom engineer it to my custom engineered specifications. I need them to custom engineer for my custom engineering. So that's why this whole box is very important. This whole approach to this box design is really my greatest challenge. It's not the electronics, it's not the programming. All that is going to be a walk in the park. I feel I'll probably have that smashed out pretty quick because I already have all the work done from years of building all the different meters and sensors. It's all about this freaking sheet metal work because I've never 3D designed sheet metal. So there's a little sneak peek on the DaVinci. I'll give, I'm going to jump into making a little metal box here, and I'm going to show you what I'm talking about with the software aside of what I've already shown you. I'm going to show you a visual representation of what I've been undergoing and the achievement that I've made this week that opens the DaVinci up to being even closer to getting done than I was expecting. And I'm really hoping this goes as I'm planning it. Let me go ahead and we're going to get started here. I'm going to jump over to sheet metal mode, create a component. I'm going to call it box one. Just doing some quick stuff here. Where's the origin? So for you folks that know a bit about sheet metal work, here's what I'm trying to do here. So I'm going to just do, I'll do 12 inches by 12 inches. Let me change my document settings to US standard inch. Finish. Okay, I'm going to turn this into a piece of sheet metal. All right, so here's what the sheet metal mode that I've been learning is opening up. Normally when I 3D design something, if I 3D design a box, if I do a standard, let me hide that. If I do a standard design, like most of the time y'all watch me design a lavatory container to hold the marijuana seeds, right? So, I'm coming in here and I'm doing something like this, I'm making my little design. Pull that up. Well, if I want to, if I want to make this edge go up right here, I have to do something like this. Can't flange an edge in solid modeling in a solid modeling environment. This is for like more precision mechanical engineering, not sheet metal. So I would raise up my edges like that and do a join operation. But here's the problem with this, and a sheet metal person will see right off the bat. All right, you're not going to have this perfect 90-degree angle right here. See this 90-degree angle? You're not going to have that when you are bending sheet metal. There's going to be a curve right here. It's going to have to curve. And, despite in the software, let me say I want to come in here and maybe I want to try to do a fillet here. Let me do a outline. Oops. So coming in here, you know, I would initially have thought like, oh man, I could just do that, and I'll put a little curve in here. And then I'll just erase this away, cut this away. And then I have some curve action. But the problem is I still have a perfect 90-degree angle right here. So yeah, I could maybe I'll just come in here and do this and that, do this and this all over again. I'll come in here and do some little fillet action. I'll have my curve right here. But the problem is we have varying degrees of thickness when we do this. So I have, you know, this is not how a sheet metal is actually going to respond. And I learned from trying to achieve what I'm trying to do here. I'm making a perfect box with holes in it, that I can't do it this way, because you can't take, like, I can't just take this I can't take this little box that I'm trying to snap up here and do this right here with it. I can't just do that and make a metal box. I can't convert this to a two-dimensional because this is a solid object. This whole thing is solid. There's no converting it to a flat file. So now I'm faced with this problem. Like, how am I going to design a chassis and put, you know, screw holes in it and have everything mount up perfectly when I'm going to have to, like, bend it on a box metal brake where there's a lot of imperfection there. And then when you bend metal, you know, you're not going to have a perfect 90-degree angle like I have right here and right here. You're going to have a radius in the bend. And I found there's a mechanical engineering term called a cape, or your K factor, and that's how much bend you can get without breaking the metal. So let me go ahead and get rid of all this here. Let's back this up. And the only way I've learned to work around this issue is I had to learn the sheet metal design process within this computer-aided drafting software. And it's a little bit different. It's not crazy hard, but it's a little different, mostly different in the sense that it automatically adds that curve for an actual radius of a metal brake or a box brake being added to the metal. So if I come up here and I did, you know, 5 inches here, and I came over here, but actually using this and wrapping the sheet metal design around a physical design, a solid design, which, you know, it's that little the box that just got through, the other box I got through making. You know, it's a bit different in how you get the two to work together. If you notice that when I raise this side up, we have a gap in between these right here. And that's because in real sheet metal design, that you're going to have that gap. These sides are going to be different. So here I can go ahead and raise this side up right here, 5 inches. Boom, I got a little box, right? But, you know, normally when I'm going to spot weld the corners together, I want to have some ears, you know, what they call ears, or I think that's what they're called, flanged out, or flanges. Let's do 1 inch. So, you know, you might put a hole in this right here. Normally, you know, if you're a sheet metal guy or a roofer or something like that, you know, you'll put a pot rivet in there. You'll drill it out. Do 0.125. You'll drill that hole out right there, and you'll put a pop rivet through it, kind of like what I'm showing you here in camera. I got a rivet right here. But what if I want to, you know, I want to see what that looks like as a flat file. I want a machine to laser cut or water jet cut this two-dimensional flat file. Normally, you would use like shear scissors, metal shear scissors, to go cutting this profile here. But with a machine, I can get digital computer-controlled precision to do this. Now, take a look at that hole. You see that hole right there? And you see that hole right there? So when I go and bend this metal at this black line right here, and I bend all of these center lines, like all of these center lines right here, I basically am bending the metal at these center lines to get that radius that that we're looking at right here, to get this radius in blue. And by achieving that radius, bending on that center line, I should be able to get my holes to line up on my Growlite chassis. So the one I showed you, the Fallout 76 design, those holes got to line up perfect, man. Absolutely perfect. And I finally found out how to achieve that in a complex, multi-component, stacked, computer-aided, drafted design using this sheet metal feature, which is like a match made in heaven for Growlite design. So now I'm going to make a perfect box. If I pull this off, y'all, if I pull this off, that Fallout 76 design is going to come right together. And when I build that and it comes right together as I am imagining in my imagination, as I'm showing in this visualization here in a computer rendered environment, it could come together and as perfect as I'm designing it, because this bend right here that you're seeing that the computer is automatically doing this bend for me. It is associating error tolerances that will likely be ran into when I bend the metal. So to reduce the error tolerances, I have to bend perfectly across those lines there. See if I can do outer inner there. So maybe I'll do adjacent here. So maybe I want to make my little toolbox to hold the you know, the EC meter, things like that. You know, I could come in here and design my little box or my little control panel box for holding some of the electronics that the user would have to calibrate. I'm really at debate if I want to put the pH meter and EC meter into it. The PPFD meter is definitely associated with the Growlite, so it has to go in there. But the PPFD meter does not need to be calibrated. I do the calibration before it's installed. It's never really needing to be calibrated after installation. But a pH meter and EC meter, they have to be routinely calibrated. So here, if I do this right here, and let's say I want to put a big old circle, or I'll put a square right here. So imagine my little computer screen, you know, like I'm just kind of dabbling in here to show you what I'm going to be doing. So maybe there's my touch screen or whatever the case is. I can come back in here and I say, hey, boom, go to a 2D flat file, and I need to cut this. So there you have it. There's the main huge learning curve I've gotten through. Now I have to execute this in the physical world, and that is really right now the only thing I'm unsure on or unsure with. But thankfully, Mr. Dustin Clements, who runs the Omax water jet cutting processors, teaching me the Omax water jet and working with me on the cut processes. He's back in town, and I will be getting with him this week so that I can cut this Growlite out. So what you're seeing here is what we'll be cutting. And then I need to finish designing the fan. So when I get off of this live stream, I got to go pick up some parts from Lowe's, and I got to go do a couple things at the warehouse today, so we can get the seed orders out 3D prints and all that fun stuff. But a lot of you who ordered grow lights from us were pretty much probably caught up and got most of your grow lights being shipped out. But I just need to design that fan just so this thing looks bona fide. You know, I want it to look as it's supposed to, minus the wires. Kind of being lazy on the wires just because, like I said, there's a lot of room in there. I don't really need to be worried about the precision of designing in the wires. Maybe if I get bored one day, I'll just go ahead and do it. It's a ton of work 3D designing wires, believe it or not. It's a mind-boggling amount of work, especially with how much wiring. If it takes 2.5 hours to physically wire a gigawatt, I can guarantee it'll probably take me two days of 3D design work to run 3-dimensional wiring inside of this. It would just be ridiculous amount of work. So that's why I don't do it unless I have to. All right, y'all. Well, thank you for watching. I'm gonna jump off of here. I hope you are excited about the upcoming DaVinci design that I'm gonna be building. Let's cross our fingers here. Hope that this thing goes as planned. I'm absolutely dead set on figuring this out. If it doesn't go right the first time around, which I'm pretty happy to say that almost everything I do with my designs goes right first time around, and it's just because when you computer precision design something, and then you manufacture it with a computer precision controlled system, everything kind of goes together, you know, as it's designed to. It comes down to putting it together physically, and one little thing I did to kind of cheat that is I really did not want to put any pop rivets or anything in the scroll. I wanted it to be sweet and smooth, very sweet and smooth looking. But here's what I did. I've got 1/8 inch pop rivet holes right here for these little guys right here in my hand. And I'm going to put them in the corners right here before I spot weld those duck ears. So each corner is going to have that pop rivet, and that's just to hold the box together. Then I'll spot weld the corner so the design will be welded. It'll be spot welded, and the holes will be lined up. I part of me almost doesn't even want to put a rivet hole into it, but then I don't want an open hole there either. Spot welding will make this thing look really, really clean. So this is the Fallout 76 grow light I am designing. I did back in 2019 talk about designing a red, gold, and Iron Man grow light with a blue diode in the center. With a I was going to mold and cast an aluminum 3D printed part, which was the Iron Man, like the I forgot the darn name of his I forgot the name of his little energy reactor. I can't think of it for the life of me right now. But the little energy reactor in the middle of his chest. So I may go and talk to some of the CNC guys at Autry Tech, and there's a 5-axis CNC machine over there, and show them, you know, see what I would need to do to see if they want to be part of Iron Man custom built grow light, and I'll have them CNC machine that that aluminum part. Then I'll throw it onto a lathe, and I'll wrap it with copper wire, make it look nice and bona fide as it's supposed to, you know, like in the movie. And we'll make a custom Iron Man grow light. I don't know. Let me know what y'all think. If y'all want me to do something like that. But we're moving pretty fast toward the DaVinci. I have everything I need to build it out. I just have to make this metal box you're seeing. This metal box is my only current true challenge. Believe it or not, this is my only challenge. As if this thing comes together the way it looks. All right, y'all, I'm gonna get to the warehouse. I'm gonna help get y'all's orders out. I'll be jumping on the Discord channel. If you are watching on YouTube, we have a Discord channel. You can go to the go to our New Kids website, click on Discord, you can jump in there. We have people in there chatting all day. Share your grows, ask questions like and stuff like that. I try to live in it most of the day. Usually, sometimes I'm busy, I'm not in there, even though it shows me active in there. Otherwise, on our Facebook, join our Facebook group. And again, hey, please like and subscribe to my YouTube channel. I have a lot of cool grow lights coming up. When I build the DaVinci, I don't know if I'll be able to top it. I think I could probably instead enhance the software. Makes me think of Iron Man. Your software is shit. So once I get that banged out, I'll go from there. I'll see if I can top my best top once I build the DaVinci. For now, stay tuned for this week. I'm hoping to video document the full build process of this Fallout 76 themed gigawatt grow light. That's going to be fan cooled. And maybe I'll I don't know, maybe I'm probably gonna auction it to. I got a lot of people who love video game stuff, man. So I may auction it off. I don't know if someone really wants it. If you really want it when I'm done building it, reach out to me and make a deal on it, because it's going to be a ton of work. The amount of money put into just cutting the square sheet out for one. If I made 20 of them, it wouldn't be so bad. But if I'm only going to make one, I have to buy a whole freaking metal sheet to cut this one design out when I could use that metal sheet to make multiple designs. I'm going to buy some stuff. Oh, yeah, this reminds me. Before I do get off here, let me show you what I want to do to it. Look, like rust. Rust spray. Black tar. Rust paint. I'm actually looking for a rust, like a rust paint to actually make the metal rust quicker. I mean, I could just leave it out and get it wet. Paint rust. There's a freaking art kit that I know exists for making Montana cans effect rust spray paint. Here, Modern Masters rust finished effect. Yeah, rust activator. Here we go. So I'm gonna use is it Dupli paint? It's a engine motor paint. You'd probably put it in a barbecue pit. It's made for engine motors. Like you're custom painting your engine motor. It's very high heat, metallic ceramic paint, but doesn't stink when it gets hot. Things like that. So I'll probably use a clear coat of that. But I want to give like a rust effect, maybe a bronze copper rust effect. Iron oxidizing, iron paint, rust activator. So the goal here is to make this thing like if you like something in the game. Okay, I don't want it painted and pretty. It needs to look like it got freaking scorched by a nuclear blast, and it survived a nuclear blast, and it's all burned up and rusty and old and shit, post-apocalyptic. Okay, it needs to look like something that you would just find walking around in the Fallout video game. And I want to use some metal rust effects, and then I don't want to necessarily use an actual paint. I want it to rust, like rust. So this should be able to expedite the process here. From what I've read, I just pour this crap all over it and try to get it to quickly rust. I may put I thought about putting patina on it to give it that like burnt, aged, been weathered up, type of look. They've been rained on. So if you can see, each one of these little paints are not cheap. They're a small little ass amount that they give you for freaking $30, man. So but it's an artwork piece themed to the game, so it's kind of appropriate, and it's going to cost. I'm already spending the money, so let's go ahead and do it. So anyhow, that's it. That's really what I wanted to last minute cover over, because the aluminum plate will not rust. So I did think like maybe I should spray paint that like a brown and black, and to kind of ghetto it up a little bit, touch it up before I put the diodes on it, give it some color, some brownish color, black or gray. And I don't know. I don't know if how I can achieve. You can't really rust aluminum, unfortunately. Um, how I can kind of weather it and make it look weathered and aged, and maybe I'll scrape the shit out of it. Like I'll scar it all up. Like I'll just scratch the shit out of it, make it look like it got blasted and shit was hitting it. You know, I don't know. I'll figure it out. I'm open to suggestions. If any of you are like metal artists and have any advice on this one, definitely open to that. So reach out to me there here on Facebook or leave a comment in the YouTube channel, and we'll go from there. But I appreciate y'all's time. Much love, and y'all have a great day.